Field in a capacitor with a dielectric. This is one of those little things that we need to look at. So we've hooked up our capacitor to a battery. We'll make that positive, negative. So we've got these positives here and negatives here. Don't forget, if you ever get to draw these, I don't think you will, but when you draw the field, don't forget to make it a little bulgy out the side. And oh, my capacitor's badly made, isn't it? Must be made in New Zealand. Alright, so positive to negative. We'll just put all our lines here. Remember, this is a uniform electric field. Little formula there for capacitance. What we've got though is capacitance is one of these made up things. It's just really looking at the ratio between the amount of charge you've got somewhere and the voltage you get produced, Q over V. Now voltage, however, is equal to ED, E being the electric field, and that's what we just put in there. So based on that, we could say that capacitance is equal to the charge over ED. So we can see from that that if we can actually decrease this electric field, we're going to get a bigger capacitance. So when you put a whole bunch of things in here, other types of non-conducting materials. Why non-conducting? Because if they're conducting, we'd lose our capacitor. We'd just get charge flow straight across it, and we don't want that. But if we get a insulator of some sort in there, the high electric field there is going to cause all these molecules with the charges in them to move a bit. Not much, just become polarized. But which way, we all ask? So we've got a negative here, so obviously the positive end is going to be up here. So we could say positives, negatives, positives, negatives, positives, negatives. So we've got the negatives near the positives and the positives near the negative, as we'd expect. What kind of field does that produce though? That then produces its own electric field, and you'll notice that the electric field there, positive to negative, so the main electric field from the capacitor goes that way, and the electric field from the dielectric goes that way. It's like a diode. So that electric field from the dielectric opposes the electric field from the capacitor from the charge on the plate. We get a decrease in E and an increase in capacitance, and so we often see that written as E naught ERA over D, this being the sort of ratio with which that is increased.